Hi, it's Ryan. This is our second example dealing with just work. This example is now Ryan is pushing our favorite crate full of fruit up an incline that is, or has, a coefficient of kinetic friction of 0.61 and is 21 degrees above the horizontal. Given that Ryan is pushing with a constant 525 newtons along the incline and the mass of the crate is 31 kilograms, determine the work Ryan does on the crate if he pushes it 8 meters along the incline. So there you have it. I drew a picture for us already. Draw a picture where there I am pushing the crate up an incline. I also took care of the knowns. So what is your go-to to try to solve this problem? Well, no, we're looking for the work done by Ryan on the crate. And so that's going to equal the force that's parallel to the displacement times the displacement. Seeing that we need a force, I think most people would think we need an FBD of the crate. And so we could look at that. Here's the crate. Try to draw this FBD out. Maybe pause the video and try to draw the FBD. If I were to draw this, I would have a weight force. It's on an incline, so that's a surface, so it has a normal force acting on it, normal to the surfaces. There's the force from the push. I'm going to say FP. And of course, there's friction opposing the motion. Now, we don't know for sure, but we could maybe even assume that there's an acceleration if the crate's going to move up the hill. In the wording, there was no mention of the initial velocity of the crate. Next, if we look at this FBD, we see that we have 1, 2, 3, 4 vectors, all angled in the direction or perpendicular to the direction of the incline, and only one vector that is not. So I think it would serve us to tilt our coordinate system by the 21 degrees. And that way we'd only have to look at components for the weight force. We would have the horizontal and vertical components of the weight force. Once you do a free body diagram, you may be tempted to sum your forces in the x and in the y direction. But to save us some time, in this problem, we were actually given the force that Ryan is exerting on the crate, and that is parallel to the displacement. So I think we could actually just solve the problem without the FBD today. So work is the force that's parallel to the displacement times the displacement. We were given the work that Ryan does on the crate is the force that of push times the displacement, and we could note cosine of phi is 1 because phi is 0 degrees because F and is parallel to S. Oh, and that just means we could substitute in the values and be all done. 525 newtons times the 8 meters. And I think that gives us 4,200 Newton meters. So this was a nice excuse to get people to draw another FBD, but you have to be careful because in this problem we were actually given everything we needed and a whole bunch of red herrings, things we didn't need. We didn't really need the mass or the friction or even the angle, and we could solve the problem. So there's a little more work for you.